fabricated with the arc. The dusting equipment utilizes an oil drum for the dust hopper fitted with an agitator at the bottom, and a blower assembly is driven by means of V-belt drives from the power takeoff of the tractor. The distributor tubes are made of welded steel pipe, and the area covered by the machine is approximately 60 feet. The field tests of the operation of this unit show that the dust delivery is uniform throughout the length of the tube. 3 8-inch holes on 3-inch centers in the bottom of the steel tubes allow a uniform distribution of the dust to the pea vines. The dust used for the control of pea weevil in the Palouse area is a 1% rotenone, which comes ready mixed with a suitable carrier such as talc or diatomaceous earth. Effective control of the pea weevil depending upon labor conditions and yield. A means of materially reducing the onion seed harvest cost was found on the Gus Huff Ranch at Wilder, Idaho, where a standard grain header has been remodeled and used for cutting and elevating the seed head directly into trucks. A 5-man crew operating header and truck is able to harvest the seed heads at a rate that would have required 50 men hand-cutting into bags. This 1-to-10 ratio of labor for mechanical harvesting of onion seeds reduces production costs and makes possible greater profit from this crop. The mechanically harvesting seeds are handled the same as the hand cuts, which are piled on straw mats and sheets for about 2 weeks period until they are dry enough for machine pressing. Onion seed production promises to be one of the most important of the rapidly growing seed industries in Idaho. Production in Idaho. The rotary disc variable cut bead topper invented by Melvin Beck is one of the simplest and most effective topping mechanisms devised. This preliminary field trial of the Beck topper was made in August of 1943 on the Beck Ranch at Burley. The operation of the John Deere beet harvester in Idaho in 1943 showed a capacity ranging from 2.5 to 5 tons per hour, depending upon the field conditions and the beet yield. Some difficulty was experienced in obtaining skilled operators for the 8 machines that were sponsored by the major sugar companies. The seasonal operation revealed that progress has been made in the mechanization of beet harvesting operations. The largest tonnage of beets was handled by equipment designed to top a single row and pile the beets and leaves in separate windrows. Loading the beets from the windrow was accomplished by several different types of loaders. The John Deere loader, shown in operation, has a capacity of 1 ton of beets per minute, making it possible for one loader to handle the topping operation of 2 or more machines. The Schick loader, developed in Wyoming, and the Hall loader, developed at Papaneset, Washington, were used for loading both from machine topping and hand topping. Ingenious farmers have been successful in rebuilding their potato diggers and small combines for beet loading use. The Keith loaders were built by the Utah-Idaho Sugar Company following the plans of the inventor, Mr. Keith of Pocatello. 2 of these units were operated in Idaho, the others being sent to neighboring states. The Keith loader is a very sturdily built machine. However, its field operation is rather slow. It is hoped to overcome these difficulties, and in general, satisfactory progress has been made in refining this machine. Mechanization of beet harvesting has reached a stage where there is no doubt but that the future beet production will depend largely on mechanized harvesting.
These views are of the trials of the Scott Viner Beet Harvester Combine at Twin Falls, Idaho, in cooperation with the Beet Sugar Manufacturers Association and the United States Department of Agriculture, Bureau of Agricultural Chemistry and Engineering. The studies are under the direction of Mr. Mervine and Mr. McBurney in direct charge. Field trials of the beet harvesting machinery developed by the United States Department of Agriculture in cooperation with the University of California has given evidence of improvement in mechanism and application. Mr. Roy Boehner of the University of California is in charge of the determination of accuracy, efficiency, and application of the harvesting machinery. University of Idaho field tests of sugar beet machinery at the Berkeley Larson Ranch at Idaho Falls in cooperation with the Westmont Tractor Company. During these trials, hand-topped and loaded beets averaged 9% tear, while machine topping and loading averaged 7 and 0.14% tear under the same field conditions. With a 4-man crew consisting of a tractor driver, a machine operator, and 2 men to clean up the beets left in the row, the machine topped and loaded at the rate of 100 feet of row in 1/2 minute. The beet harvester showed an advantage of 5 to 1 on a man-hours and time basis, or a saving of 80% of the hand labor involved in the beet harvesting operation. The truck requirements were 8 times greater for the machine than for the hand operation. This gives a distinct advantage to the transport of the beets from the field. The ultimate development of the beet harvesting equipment should include a 2-row top and lifter combination with a basket-type hopper dump mechanism that would permit loading the truck at the ends of the rows. The mechanization of beet harvesting has not developed to the stage that it has influenced the contract price charged for This power horse tractor is a four-wheel drive unit steered by clutches which transmit the power independently to each set of tandem dual wheels. The tractor is driven by a set of reins attached to the steering levers, which also control the master clutch and gear shift. 10 feet 8 inches at the center ridge. The bins are arranged on a 60-degree angle, which permits the trucks to drive through the cellar and back into the bin section. 36 bins provide a capacity of 61,200 bags, or 170 car loads. The cellar is provided with a ventilating system consisting of 3 large vents above the middle aisle and 4 18-inch inlets along the outer edge with air ducts at the bottom of every bin. By means of electrically operated potato pilers, the bins are filled to the height of 10 to 12 feet. The potatoes are washed, sorted, and packed on electrically operated tables under modern fluorescent lights.
Mechanized potato harvesting in Idaho. Reducing the peak labor requirements for potato harvesting can be accomplished with the trailer picker used with a standard digger, or with the potato combine, which is a modified digger equipped with finer, pot and stone remover and bagger. These machines easily save 13 man-hours per acre, or 23% of the total man-hours required for harvesting potatoes. The use of the trailer picker slows down the operation of the digger to about 1/2 of its normal digging speed. However, it reduces the number of man-hours required for handling the potatoes, which is about 1/2 as compared with the field picking and bagging. The number of successful potato combines have been developed, both the single and two-row type. Carl E. Johnson of Idaho Falls is the inventor of the machine used by Harold E. Nagel of Parker, Idaho. 2 of these machines were included in the equipment that Mr. Nagel used to dig 400 acres of potatoes. The machine operating on Mr. Johnson's place at Idaho Falls shows his latest development in vine and clod removal. Labor-saving methods for slicing peas. Frank Bernard of Moscow, Idaho,